Hi, so we're going to talk about the limit to quicksort recursion, or really kind of what quicksort should do when the input becomes small. So we've just studied median of 3 as a way to pick the pivot. Now, it has a small problem when the size of the input is less than 3, right? Because it needs 3 samples. And as a matter of fact, when the size of the input is small, and by small, we usually mean probably maybe 10, 20, maybe sometimes 30 or even slightly bigger. But anyway, when the size of the input is small, quicksort in general, can actually become very inefficient for 2 reasons. One is because those partitions, they've already gone through quite a few rounds of quicksort, so they are probably nearly sorted, if not already sorted. So we've already seen that quicksort can be efficient when the partition, or when the input is trying to sort, is almost sorted. So that's one problem. And then another problem could be just the recursion itself. Recursion is never free, right? So that's why it's actually a very common practice that where for quicksort, when the size of the input becomes very small, that we switch to another sorting algorithm. And this sorting algorithm would be one that performs well when the input is nearly sorted, and it also kind of sorts the input kind of very naturally in place. And we know one such algorithm, and that is insertion sort. So yeah, if you can remember the details about insertion sort, now will be the time to review it. So in terms of the actual implementation, this is what we'll do. So we actually bring in the insertion sort as a nested function inside quicksort _is. That kind of stands for insertion and quicksort using insertion sort. Anyway, now the insertion sort, if you remember the way we used to write it, it sorts the entire input. However, we don't want it to do that anymore, right? Because quicksort, it might operate only on parts of the input. So that's why we have the start and end index. And then we, for this quicksort version of quicksort, we define a little constant that kind of says the recursion limit. And so this is the input size when the quicksort will switch to insertion sort. We set it to 15. In your assignment, you're going to ask to try the experiment and come up with the best number. Anyway, and then the way we use it is basically if the start plus that limit, if it exceeds the end, then we know the size of the input is smaller than 15, and then that's when we'll just switch to insertion sort. Otherwise, we did what we did before. Okay, and the modification to insertion sort is fairly straightforward. Now that we have the start and the end index, so instead of starting at always 1, we start at start plus 1, obviously, and when we where we use the end at the end of the input, now we end at what we are told to end. And then also, so when we kind of go back in the sorted portion to try to figure out where to insert, we don't go all the way back to 1. We go back to at most the beginning of the input that we're supposed to operate on. So that's kind of just a quick look at how quicksort can switch to insertion sort when the size of the input is small.